Hello, this is Susan Poss. I'm still working in Chapter 4 on graphing linear equations. This is Section 3, and this is the third video from Section 3. So this last little bit's just kind of a hodgepodge of some miscellaneous things to pull together here at the end of the section. The first one, we're trying to write the following equation in slope-intercept form, reduce all fractions to lowest terms. You saw me do that previously, so if you watch the previous video, I'm going to be relatively quick with this. There's my left side, right side. Remember, my goal down here is to get y by itself. So I'm going to begin by moving a couple of things off the left-hand side. I'm going to subtract the 3x, and I'm going to subtract the 7. That will leave the positive 7y still standing on the left-hand side. And the last thing I need to do, I think I'm going to come out here to the side where I have a little bit more space. Let me recopy this. The last thing I need to do is come in here and divide by 7 so that I get that positive y by itself. Remember, that was my goal. So that's the way it looks after I've reduced all the fractions to lowest terms. And it did not ask me to do this, but I can tell you the slope is -3/7, and I can tell you that the y-intercept is at 0, -1. All right, now this next one is sort of moving us on into section 4. This one is asking us to find an equation. It's not giving me the equation, it's giving me some information. It's telling me a point, and it actually turns out that this point is the y-intercept. You know that because the first coordinate in the pair is a 0. So there's the point 0, 5. And from there, if I change color and count up 1 and over 1, 2, 3, 4, 5, 6, you get an idea of what this line looks like. So we have the picture, but we don't have the equation. We're trying to find what the equation is. So there's my y-intercept, 0, 5. Here's the slope, 1/6. Why can't I just go right ahead, pull out my slope-intercept form, leave in the letter y, replace the letter m, leave in the letter x, and replace the letter b. So there you have an equation in slope-intercept form that puts in the slope of 1/6 and keeps the y-coordinate for the y-intercept at 5. Here's another one that does something a little bit different. Write the following linear equation in slope-intercept form. So again, remember that goal is to get y by itself. And I personally would like to have the y over on the left. It doesn't really matter, but I'm going to turn the whole thing around. And then I'm going to come in and divide by 9. And that reaches my goal of getting y by itself. So, all right, so the funny thing I wanted to show you about this one is that this has the variable y, it has the variable x as an x term, 2/9 x. Does not have a constant. So when that happens, you would assume that this constant is a 0, and you would assume that the y-intercept is at 0. So this one's going to pass through the origin. And then for the slope, which is this 2/9, I count up 2 and run 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I were to sketch this linear equation, it would look something like that. Okay, so that's kind of an unusual case. When there is no constant, the line passes through the 0, the origin. This next one, We're asked to put it into slope-intercept form, and again, remember, that means I want to get down here with y equals something. Notice this particular one does not contain the variable x. Makes it kind of an unusual case. So let me go ahead and add 15 to both sides so that I can get the y term isolated. And then dividing by 5 on both sides, you can see that y is equal to 3. All right, so that has no x term. So what is the slope of this line? Turns out that this one is a horizontal line. Anytime you come up with something that says y equals a number, no x variable in the equation, just a y. I think we did some of these in a previous section. If we graph this line, it's going to look something, oh, that's terrible. Let me try and clean that up a little bit. And let me change the color for that too. So if we try and graph this line, there, that's a little better. That's the line y equals 3. It has a y-intercept here at 0, 3, but the slope of this line is 0. Anytime you have a flat line, the slope is 0. All right, one last little group of things to talk about here. Standard form we talked about earlier puts the x term first, the y term in the middle, and the constant over on the right-hand side. If you have no variable y, then standard form would be x equals the number. And like that previous one, let me scroll back down where we didn't have an x term, the standard form we wanted there, or the form we wanted it to be in, was y equals the number. And you see that's what I did here. I got it into y equals the number, and we graphed it. This next one has only the variable x in it. So what I need to do with this one, and I know this is counterintuitive because I've been saying over and over again, get y by itself, get y by itself. Well, there is no y. So now I'm going to say, when there is no y, get x by itself. And when I do that, you can see that I get x equals -5. Turns out that anytime you have something of the form x equals a number, it gives you a vertical line. And you can see I've graphed it back over there. This one does not have a y-intercept. It runs parallel to the y-axis. All right, this next one asks me to write the linear equation in standard form. Standard form. So remember what standard form looks like. That puts the x term first, the y term in the middle, and the constant over on the right. So I see only one term that appears to be out of place. That 4y needs to move. So let me begin by subtracting that 4y off of the right-hand side. Now all we're doing here is manipulating the position of these terms. So now I have it in standard form. I have the 3x appearing first, I have the -4y in the middle, then the equals mark, and finally the 10. So that's what you do when you're asked to put something into standard form. All right, a couple of things that you need to memorize here. We said this earlier. If you have a vertical line, it will be in the form only the variable x and some number. That will have an undefined slope. If you have a horizontal line, that will be in the form y equals some number, and it will have a slope of 0. Something to memorize. So here's what you want to be able to do with that. You want to have that so firmly established in your head that you can look at this without working anything, and when you see that y is equal to 4 and y is the only variable in here, you know that the slope is going to be 0. 1, 2, 3, 4, and you know that the line is going to be a horizontal line. So again, you want to be able to do all these things very quickly in your mind. If it only has the variable x, no y variable, You know that the slope is undefined. Again, memorize this. And you know that the line is going to be a vertical line. I didn't label this. Let me label that. And I labeled this one backwards. Sorry. There, that's better. There, now I have it right. This next one has only the variable y in it. So you know that that slope is going to be a slope of 0. And you know that the line is going to be a horizontal line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's negative 11 down here. So that y-intercept is 0, negative 11. And this last one has only the variable x, and so I know that that slope is going to be undefined. Again, if you have all this memorized, you don't have to waste a lot of time trying to think your way through something. And I know that this graph is going to be 1, 2, 3, 4, 5, 6, 7, a vertical line back here at x equals negative 7. All right, so that's a good place to stop. Hope that helps you to get through section 3 and chapter 4.